Hello guys, it's Boris here. Uh, let's continue with the series on the problem solving. Um, it's very important for some interviews because they want you to solve some problems with algorithms. We will use today. We will unlock the greedy approach here. Okay, we are going greedy. Uh, Now I want to tell you I have failed on this task on this problem on the interview before time, and they didn't give me the lead code one, but it was refactored. This here was refactored, but it was the same program, and I didn't have this explanation here. Okay, I just had the input, and they told me what I should gonna do. I even didn't have this. So for 30 minutes you cannot solve this very easy without practicing and uh, thinking algorithmically and logically, I mean. And Okay, let's break down the solution, the description. Uh, we are given an array of prices. Okay, here is the array. Where price I is the price of a given stock on some market on the each day. This means this is the value of the stock on each day. The day for us it's index 0, but they say it's day 1. This is here each day is just the index here, right? On each day we have the value 7 of the stock, right? Of the price, the stock of the price. So we have break down this array, what it represents. It represents time if we use the indexes, and the values of the indexes in the array are the prices of the stocks, right? Perfect breakdown. On each day, we may decide to buy or sell the stock. You can only hold at most one share of the stock at any time. However, you can buy it, then immediately sell it on the same day. Okay, there are three different things here. On each day, you may decide to sell the stock. This means we can buy here and sell here, and this is the end. Or we can buy here, sell it here, buy here, sell it here, and we are done. Okay, but this here, at most one share of stock at any time, means we cannot make four transactions, for example. Here we make four buys here, 7 1 5 3, and we going to sell it here on the fifth transaction we do. They say at most one share of stock at any time. This means we can buy here, sell here, buy here, sell here. We cannot accumulate buy or sales. I think I'm clear about this. It states, however, you can buy it, then immediately sell it on the same day. This means we can buy it on the first day, on the second day, sorry, and we can sell it in the same day. But this will always going to be zero, no income for us and no losses for us. I think this is because they can tell us here's your input and our answer will be zero profit because we will buy the 5 here and sell it here. This is the purpose of this here. And what they want us from us is to find and return the maximum profit we can achieve. Okay, so if you got this description, it's hard to think about it abstractly, but if we draw a chart and imagine we are in the real world life scenario, because those are stocks and you can trading some crypto or something, or you have stocks and buy and sell, and you can think it this way. We have $100 and imagine we know the future here, and the chart is defined like this. Okay, and imagine you know this future. What we will do to optimize the total the total profit? You buy here, right? You buy here. I will denote B with B. I'll buy with B abbreviation, and you want to sell it here. I'll denote sell with S abbreviation, and because here is the time on the horizontal, the price is at the vertical. Okay, so this here will give you the most money if you sell it here, right? Then you don't want to, the other thing is you don't want to buy when it is rising, right? You want to buy when the stock is going down, and but you don't want to buy here or here, right? You want to buy exactly at the optimal price. You want to buy here and sell at the optimal price. Sell here, right? And we are going greedy here. We will always buy at the optimal and sell at the optimal. Buy at the optimal and sell at the optimal, right? We will not, for example, sell here because it's not optimal. In the real life, we don't know this because if we are here and we have buy the stocks here, we can tell we're gonna have $1,000 and we will not wait to the optimal because we don't know what will happen, right? But here we can know this. But you can imagine it like that abstractly to approach the problem from a real life scenario. We don't know the future here also because this input will not be the same when we hit the submit button, right? Because it will be different and very large input, for example. But my approach will be, I will explain it how I will approach this program. Here is the input, right? And we are start implementing. But let's see. Those are the days, right? 1, 2. I know this is the zero index, but I will write it from 1 because those represent the days here, ith day. But it's actually 0 nor here, index 1 here, and so on. So I want to look backwards. I'm going forward, iterating the array. But I want to look backward. What this means is when I'm at 1, I want to check the previous element and see 1 minus 7 is minus 6. It's not good idea to buy here, right? When I'm at index 2 at day 3, I look at the previous element and I see here 5 minus the previous element, which is 1, is equals to 4. I can get 4 profit. And I will buy here and sell here, but we are looking backwards, right? Okay, here we made one transaction and we have 4, right? I will not wait because you think, okay, I will buy at 1 and here, somewhere here, there can be 9999 something like this, and I will sell this one here, and this is the maximum profit. But the greedy approach doesn't work this way because we must make transactions non-stop. because you don't know. Here it can be some big number, but in the middle of this, if you are saving your money, there can be also big number. So you should be greedy, right? It's a bit hard to explain the greedy approach, but believe me, you will start to think, I will not buy, how to buy and sell at the maximum, and you get lost. And if you see something like this just go greedy. We will not losing by doing it most of the times. Um, because it's tricky for the mind to understand this. If I buy one here, I will wait the whole array to see some big number, and if I buy and sell in the middle, I can not make this profit. It's not the case. So we proceed here. We made one transactions. We are looking at this example. Then we will be standing here and we were looking at the previous element and we will say, okay, 5, 5, excuse me, 3 minus 5 is equals to minus 2. So, it is not a good idea. When we are standing here, we will look at the previous and we will say 6 minus the previous 3 is 3. It's a good idea to buy here. We have a 3 profit, right? And when we are standing at the end of the array, we will look at the previous. Okay, so 6 minus 4. Sorry, 4, I mean, we are at the current element 4 minus 6. I mean 6 minus 4. 6 minus 4 will be 4 minus 6. For God's sake. 4 minus 6 minus 2. So it is not a good idea to do this. And in the end, we have 4 and 3, which is 7, which is the profit expected here, right? So we're gonna implement this, but the implementation is easier than the approaching the problem. When you understand the logic, it's easy, and you should understand. You should go greedy. You should buy and sell every time, not to wait to buy and sell, to think this way. I will wait to sell at some point of time. You sell immediately when there is a profit. This is the greedy approach. And let's call it out first in the IDE. Okay, we should iterate the prices. First, we want to accumulate the result, right? Then we need, I'll make initialization of the wrapper class of the integer because I need to set it to null. This will be the previous stock, it will be null. Okay. Then I'll iterate the price array. Let's say this is the current stock. Okay, we iterate over the array. Then we must check pref element, pref stock is different than null, right? Because and I'll tell you because you remember we have some array, right? And here is the zero index and the first day. Okay, this is the first day, the zero index, and I want to look previous, not forward. So the previous element is no, right? We cannot compare this element with no. So we will have a problem here. So I check for the first iteration if this is different than no. If it's no, we are at the first element here in the array. So this is the first condition that we must check for because it's the corner case here. It's not exact corner case, but you understand me. So the current stock, what is, let's understand this statement here. We are looking at one, right? And the previous stock is 7, then it's 5 and so on. But when we are here, we want to check this element, right? And the current stock will not be greater than 7, right? 1 is lesser, and we don't want to buy 7 because we will lose from it. Because if we buy here and sell here, we will be minus 5 profit, right? But when we are here, we will check if the current stock, 5 in this case, is it greater than the previous stock, which is 1 right here? Yes, it is. So we will say 5 minus 1, the current minus the previous, will give us 4, and we will add it to the result. We will not wait for the future. We do it greedy right now. When we see this condition, we buy and sell, right? Um, so I will tell why this will work, okay? But let's code the condition. Here, if we see this condition, which I explained, and we will gonna accumulate this result from the transaction of both stocks. For example, one transaction is represented by 5 minus 3, we got profit of 2, and this 2 will came here, right? So the result will be accumulated with this 2. It will be added to the result. And then we want the previous reference to point to the current stock. In the second iteration of the loop, this will be true because we will have the previous stock right now. And we will check again this condition. Okay? So after we iterate the loop, we return the result. It's so simple, but you should get to this line of code. 16 lines of code, right? With the class definition and the method definition. So let's enter debug mode to be very clear why we have done this. So I will write the input again, sorry. I mean, just a second. We have 7, 1, 5, 3, 6, 4. Those are the stocks. We are in this case right now. and we will fail at the first check for the previous stock don't equals no, right? Okay, you can see the current stock is 7, right? But we don't have previous, so we don't enter the if block. And the previous stock reference to the current stock right now. Refer to the current stock. Now, the previous stock is 7, right? The previous stock is 7. Then we proceed and we can see the current stock is 1. And we will not enter the loop because this here, we are here right now. And we check, hey, is it the current stock at 1 bigger than 7? No, it is not, because we are gonna lose 6 here, right? $6, for example, from this transaction. And we will not do it. So we proceed. We say previous stock is equal to 1 now, because we are going forward. We are actually going in this direction, forward direction, but we are looking backwards, right? We are going in this direction, but we are looking for the elements in the opposite way. So now the current stock is 5 and the previous is 1. We will have profit of 4 right here, right? And let's proceed. The result is 4. It's accumulated in the result variable. Now the previous stock will be 5. The current stock will be 3. 3 is not greater than 5. So we proceed. Now the previous stock is 3. The current stock is 6. So yes, we should accumulate this result to the result, because here you can see 6 and 3. 6 minus 3 is 3, right? So we want this in our result, right? So we are going forward and the result is 7. Okay, and this is the answer actually. This is our answer here. Output 7, okay? So, to tell you why the greedy works here is because, see, if we have input like, sorry, the drawing tool is a bit tricky, and this is why I write some code that's not in place. Sorry for that. But the point here is to understand our algorithm logic. Here, if we have, for example, 7, 8, some big number, 9999, 2, here we are going to be right. We are going to skip this. We are going to skip this, okay? Because this is not greater than 8. This is great. I mean, we are going to sell here. Sorry. I mean, if we have 7, 1, like in our example, and later we have only increasing numbers, like increasing for us is in the opposite order. So let's take, for example, this case. I want to explain why greedy work here. It is a bit tricky. If we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have this here. And they tell you again exactly the same description of the program. And you can tell, hey, I will buy here and I will sell here. You can start thinking about this and you tell the output will be 8. Let's check if we are going greedy, what will happen. Right, this is okay, totally fine. It will be 8. We are starting greedy by doing this logic here. And we say, is 2 is greater than 1? Yes. We made one transaction. 3 is greater than 2. We made one transaction. 4 is greater than 3. We made one transaction. 5 is greater than 4. 1. And you know the drill now. Everything is 1, 1, 1, 1. Okay. Now let's accumulate this result. 1, 2, 3, 4, 5, 6, 7, 8. So you will not miss the big buy and sell, right? You see this? And I wanted to show you this because you can start thinking, oh, I must buy the minimum and sell at the maximum, but they tell you you should sell and buy. You can sell and buy, and we do. Uh, you can sell and buy every day, and we do this. They didn't tell us you buy one time and sell one time and give us the answer. They say us each day you can make a transaction, and you see this. If we buy here and sell here is the same like we make 1, 2, 3, 4, 5, 6, 7, 8 transactions. It is the same. So guys, um, you see here, if we have rising in the stocks, we will always catch this with the greedy approach, right? It's same if we take one big transaction here and or one bigger transaction here, and you can see this by why we cannot lose, because if we have decreasing order here, for example this one, right, with this greedy approach, with this logic, what will happen? We are here, 13 is not larger than the previous one. We don't take this into an account. We don't take this into an account because 10 is not greater than 13. 5 is not greater than 10. 2 is not greater than 5. And 1 is not greater than 2. So we will not do any transactions here. And you can see if you look it forward, you will see you cannot buy here anything to make profit. You can buy here and sell here, like they say in the description. This is, and you got 0 because you cannot make profit, right? So this is the greedy approach, and it is working. And think about it this way next time when you have some similar questions like this one, similar problems. And I want to show you in the current video, if we get to the problem list and we see this medium. Okay, they say here, this is the grid tag, dynamic programming. Yes, it can be applied. Here we can see this easy program. By the way, this program can you can mistake it with start solving it with sliding window or something like this, but it is not a sliding window program. Here I give you the result instantly because it is very easy. Here is the same program, but we have to do only one buy and one sell. It is a lot easier. What we mean here, we have the same input, like see, but see the statement. You're given an array prices where prices I is the price of the stock of the day, right? The same thing. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. Return the maximum profit you can achieve from this transaction. If you cannot achieve any profit, return zero. What is the difference between these two is that here we should take the smallest element, right? And sell it at the higher price. So we should sell it here, right? We cannot make more than one buy and one sell transaction. We have only two transactions here. Only two. In the medium problem, best time to buy and sell stock 2, we had the chance to buy and sell on every day, on each day, right? On every single day. Here we have just one chance to say this way. And this is easy, but if you see the solve rate, it is 54, sorry, percent. And this is less than the other question. And how we solve this? We keep track, here it's not greedy, but we keep track of the minimum number, what we say here. We define a result and a mean number with an integer max value. Here we iterate through the array with this for loop, and we set the mean number to be the minimum from the mean number and the price. This means we will keep track of this minimum number we want. For example, we will came here, it will be 7 first, the minimum number here, it will be 7, right? Then when we are here, it will be 1, right? The minimum number will be 1. And when we are here, 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 and here, it will be still 1 because it's the smallest number. I use mathmin function here. If I use if else, it will be more clear, but I think you know this, what mathmin does. And for the result, we make this, we see the result, which is greater every time, the result or price I minus the minimum. So what will happen here? We have this input. See here. Okay, we have this array, right? And we are in every iteration, we update the minimum number. We will came to here. When we came to the smallest, this will not be updated until the end of this array. Okay, for sure. And this here will check if 7 minus 7 will be 0, right? The first iteration. The mean number will be 7, because first it's the max value of the integer, and it is smaller than this one, and it will become 7, the mean num. So sorry, I wanted to write it right in camel case. Mean num will be 7 at first, then it will become 1 at the second iteration, and it will never be a lesser element in this array from here to the end. This applies for every input you can imagine. When you find the lesser number, it will be to the end of the array. So this condition here tells price I minus num. Every iteration you will check the current value, for example 5, minus the minimum number, which is 1. The result will be 4 here, right? So you're going to go here. You're going here. 3 minus 1 will be 2. Then 6 minus 1 will be 5. Then 4 minus 1 will be 3, right? And which is the biggest one? It is 5. And the answer is 5. Let us try other input. Sorry. For example, we have 100. We have 50. We have tell 5. And we have 999. And again, we have 1. Okay. I made this input in my mind really quick. So on the fly, I mean. So let's see what will happen by applying this. First, the mean, I will abbreviate it like m, will be 100, because 100 is lesser than max value of the integer type. And then we will check price I minus mean number will be 100 minus 100, it will be 0. So the result says compare result with this statement and return the largest. So it will return 0, because 100 minus 100 will be 0. Result is 0. Then we will be standing here, and okay, the mean number will be 50. Okay, and 50 minus prices I will be 50 minus 50, it will be 0 again, the result will be stay 0. And when it is staying 0, actually we are not doing transactions this way. You understand this? We don't buy here, we don't buy here, right? And we came here. Now the smallest is 5. Here the mean num is 5. And we again check this condition. But again, 5 minus 5 is 0, right? So we don't make this transaction. We didn't make this transaction also. And when we are here at index 3, this get ugly. At index 3, right? What will happen? The mean value is 5. Okay, and now this value, the price I, is not lesser than the mean value because the mean value is 5. The current value price I here is this number. This will not get updated, this value. This value here will not get updated. So then we say result is equal to the result, which is 0 for now. And the second statement is price SI, this number, right? Minus the minimum number so far, which is 5. And the result will become this, right? And we have done one transaction here. Okay, we have done this transaction, and in this and we have a profit 1994. So they tell we want to maximize your profit, but choose a single day to buy. We have only one chance, right? And choosing different day in the future to sell that. We have only one chance to buy and sell and to get the maximum profit. So when we came here, this mean value will become 1, but there is no more elements, so we are in the end, so we cannot make profit here. And if we compare uh, the current element with this, I mean, what I mean, the mean element is 1, result is the maximum of uh, this, the current result, and this statement, price I minus my num, which is 1 minus this big number, and we will get this number. So which is bigger, this or this? This is greater, right? So we don't care about this one here. And the logic is like an iron here. So with this 12 line of code with the class and method definition, we have solved this problem, right? And you saw the difference between the two. The second one for me was really very trickier. This here was easier for me to solve it. And for those who don't know what we are doing here, every time, for example, we have found a transaction with which profit is 30. Okay, the result is 30. The next time when we find from this condition, when we find from this condition a greater result, this here is, for example, 50, then R will getting updated. But those methods are Java methods, so if you know Java, you can read the code. Because without using those two functions, min and max, we will have a lot of boilerplate code, and it will become very larger and look more complex, and it will be harder to read. Because of this, we use these min and max functions. But I breaking down for you what the statement does, right? Each iteration. And the fun fact here is, if you look at the problem list, I mean not here. I want to go to LeetCode. Okay, I want to go to LeetCode and show you best time to buy stock, blah blah. Here you can see both the programs. You can see the easy one, which is really the easier for me. Have lesser acceptance rate than the medium program, and this is strange for me because this is really more easier than this one, because here we use greedy, here we use nothing. We use our minds in both, but here there is no paradigm or something, some technique like sliding window, greedy approach, and so on. Here we have greedy, and the acceptance rate is almost 70. So I don't know. I will try those two in the future, and I will make a videos on them. But for now, I had this on an interview. Okay, and I have failed. So I wanted to show you this question. So I solve problems also on other sites like Code Forces and HackerRank. So don't look at this here, those statistics, and say this guy didn't solve 100 problems yet. I started coding from some time, but it's not the main platform I solve problems. And last I want to say, let me know in the comment which of those, if you approach it by yourself or in general, which is harder for you. Because this is strange here. I cannot accept this question is easier than this, right? I don't accept this. Because I have solved it myself, both of them, and without help, without watching videos. So this is more harder for sure. Tell me in the comments. It can be otherwise. I don't know. Or if you have better solutions, tell me about them. And last, let's submit this to see if it works, because we didn't do that. Right. Let's first run it. Let's submit it. Okay, we beat 100% of the solutions in Java, and we are running in 0 milliseconds. What will be the complexity? What you think? I think it's all fine, right? Let's see. Or I'm out of... Okay, so it's all fine. Yeah, we have only one for loop. No need for optimizations or some kind of this stuff. Even for me, it will be harder to come up with this time complexity for runtime, because I can't imagine a solution with loops here. It's hard to imagine it. I don't know why. It's not intuitive for me. So please write in the comments, copy paste your solutions if you came with something better. And this is from me, guys, for now. And we'll be keeping in touch with you. So bye bye and have a good day and weekend. Bye.